Let's compute inner product using the given vectors here. We have x, y, and z, all of them in R2, and we have these components for each. Take note that we already defined what inner product is. At the same time, we already done proving those properties, and we will be applying those properties specifically on the last two examples here. So for the first, you have here the inner product of x and y. Take note, it's just a product of the first components and plus the product of the second components. The component of x is 2 times 3. So you have here 2 times 3. Sorry for that. Plus, take note that the 3 here is the first component of y. 3, the second component of x, times negative 4, which is actually 6 plus negative 12. So you will have here negative 6. Take note that inner products are actually scalars. So we know that the result would be constants here. So that's how we compute inner product. For the second, you have here z and z. So simply multiply z to itself. The first component is 5 times 5 plus 1 times 1. So you will have here 25 plus 1. You will get here 26. Still scalar. That's how we compute inner product. Now, for the next two examples, we'll be using here some of the properties, but we are also going to show the process if not using those properties, because this is where scalar multiplication is present. Take note that we have that property which states that if we have your x, cy, you can just simply take c and take the inner product of x and y. That's the property, one of the properties we have learned in the previous video. And since we already have the value for the inner product of x and y, here for x to y, that's our c, so twice the inner product of x and y. So you will have here twice the inner product of x and y is negative 6. So you will get here negative 12. See, it's even shorter. But of course, if you would like to really see the same answer using this actual process, so you could have here 2y. If you're not comfortable with this property, your y is actually again 3 and negative 4. 3, negative 4. So you will have here 6 and negative 8, right? So you have that. And if you're going to operate that to x, to y, knowing that our x is 2 and 3, so you'll have 2 times the first component 6 plus 3 times the first component of negative 8. This is actually 12 plus this is actually negative 24. You will still get negative 12 even if you will start with this. So they have the same result. The first one is using the property. This is using the multiple first before applying the inner product, and you will still get the same result. Okay, so it's up to you, but I believe if you are familiar with the property, you can use the property. Similar thing with this last here. If you have the sum on the second portion here, you can just break them into two different inner products, x and then y, plus x and z. Okay, that's the property we have proven in the previous video. So since we already know this inner product is actually here, negative 6, what we just need to do is to solve for this. The inner product of x and z is equal to the product of their first and second components. X is 2 and 3, z is 5 and 1. So 2 times 5 plus 3 times 1, you will get here 10 plus 3, you will have 13, right? This would mean when used that here, our result here is plus 13, you will get 7 for the result of that. Now, this might still look a little bit longer, but it's because we don't know this yet. Okay? But if we know this already, and we know this already here, so we can automatically add them to get that one. Now, what if you would really want to use x or y plus z, and to verify that if you have the same result as 7? So, y plus z, the component of y is actually 3 and negative 4. So, 3, negative 4, plus z is 5 and 1. So when adding them, 3 plus 5, negative 4 plus 1, that's actually 8 and negative 3, right? So if you would like to take that it's what do you call this one, inner product with x, and x again has components 2 and 3, so 2 times the first component, which is 8, plus 3 times the first component, which is negative 3. This is actually 16. Sorry for that, this is equality. Let me rewrite. 16 plus negative 9, which will give you 7. This is still the same result as this. So again, even if this still looks longer, if you already know what are this, you don't need to add the two vectors and then take its result and the inner product of the other one, because simply add it like this. But of course, you really need to memorize or familiarize the property, and that is still the same with the longer process. This is all for some examples for computing inner products. Thank you very much for watching.